Hello all, this is Trusha Patel. Welcome to the lecture of Memory Allocation and Memory Management. Now first let's talk about the subroutine. Now what is subroutine? It is nothing but the part of a program which we are writing separately. Now the subroutine can be implemented either as a procedure or as a macro. As we all know that if we implement as a procedure, from main program the control will be transferred to the procedure, and after execution of the procedure control will go back to the main program. While in case of the macro call will be replaced by the macro definition at the time of the pre-processing of the program. If my procedure is returning something, then it is called as a function. Now, in all the programming language, we have one main program that itself is a procedure, and we may have the certain subroutine, and from main we are calling that subroutine or the procedures. There is another possibility that procedure will call itself. In that case, we will call them as a recursion, or the procedure can call some other procedure as well. Now, execution of the procedure will refer as a activation of that procedure, and for each activation of the procedure, activation record is going to be maintained. So what is there in the activation record? Let us take one example. We have procedure P1 which is calling procedure P2. So here my P1 is called the caller and P2 is called callee procedure. Now inside the P1 I am calling P2 with some variable A and B. So in activation record of P2, the actual parameter, that is A and B, is going to be saved. Then return value is also saved in the activation record. So inside my P2 procedure, if I am returning something, let's say return X, so that return value will also be maintained in the activation record. Now next is the local data. So inside my P2, let's say if I have integer a comma b comma c, so this all a b c are the local variables, so that local data will be available in the activation record. Next is the temporaries. So if we have expression like a is equals to b plus c multiply by 2 divide by 3, something like that. So as we know that the entire expression will not be performed in one go. It will first do t1 is equals to c multiply by 2, then t2 is equals to t1 divide by 3, then t3 is equals to b plus t2, and then the value of t3 will be assigned to a. So this t1 t2 t3 are the temporaries which are created, which will also be saved in the activation record. Now next is the access link. So apart from this ABC, if my P2 procedure is using some non-local variables, then the link of that non-local variables need to be maintained in the activation record, but this is optional, as not necessary all procedure are using the non-local variables or the data. Now next is the saved machine state. Now many times it is necessary to save the state of my machine before I call any other procedure. So that machine state is going to be saved over here. And the last, that is a control link. So P1 is calling the P2. So P2 need to be maintained the link for the P1, so that after execution of the P2 we can return to the P1. So that link to return to the caller will be maintained in the control link. Here this is also optional, because as we know that in case of the main we don't have any caller, so in that case control link will not be there. Now next we are going to talk about the activation tree and the control stack. Activation tree depict the way control enters and leave the activation, while the control stack will keep track of all the live process activation. Let us take one example here. One main program and the four procedures are given. Now, as we all know that the very first call will be done for the main procedure. So in the activation tree, main will be the root. Now, execution of the main will start from the beginning, and after executing certain statement, there is a call for the P1. So main is calling the P1 and the activation record of the main is available in the control stack, and above that the activation record of the P1 procedure is there. Now P1 is having a call for the P2. So P1 is calling the P2, and activation record of P2 is available on top of your stack. Now P2 is having a call for the P3. So P2 call P3 and activation record of P3 will be entered in the stack. Now P3 is not having call for any other procedure. So after the execution of the P3 is done, we will return back to the P2. So activation record of P3 will be deleted. Now once the process of the P2 is done, it will return back to the P1 and the activation record of the P2 will be deleted. After execution of the P1 will return to main and P1 activation record will be deleted. Now after executing certain line in a main, we again have a call for the P4 procedure. So from main, P4 is called and activation record of P4 will be entered in the stack. Now we can see that P4 is having a call for itself. So P4 is my recursive procedure. Now let us take for example, we are having certain condition, and because of that the P4 will be called for 3 times. So P4 will again calling the P4. So new activation record will be added. Again it will call the P4. So new activation record of P4 will be added. Now the third call will be complete and it will return to the second call. So activation record of P4 will be deleted for the third call. After completing the second call, it will return to the first call. So activation record for the second call will be deleted and first call will be complete and it will return back to the main program. So the activation record for the first call is also going to be deleted, and at the last when the main is complete, the activation record for the main is also going to be deleted. Now whenever we are talking about the data, there are three things. One is name, storage and value. So what we are saying is we are having some XYZ variable which is having memory location 1000 and the value of that XYZ is 35. So this XYZ is name, 1000 is a storage or the memory location, and 35 is a value. So binding of the name and the storage, this function is done by the environment, and binding of the storage and the value is done by the function which is called state. So environment will give you the information of binding of name and the storage. That means XYZ is allocated at memory location 1000. This is given by the environment. And storage and value binding means at the 1000 memory location I have a value 35H that is given by the state. Now there are three kind of allocation. One is static, stack and heap. Now static allocation will always done at the compilation time. Stack allocation will be done at the runtime using a stack. And heap allocation, it will allocate and deallocate the storage as per the requirement at the runtime. Now starting with the first, that is static allocation. as we have discussed that the names are bound to the storage at the time of the compilation, and because of that there is no need of runtime support package. Now this binding of the name and the storage cannot be changed at runtime. Every time the procedure is activated, the names are bound to the same storage. That means if I am having some procedure P1 and I am calling this procedure P1 for 3 times, and inside that procedure I have some variable A, then for all 3 call it is assigned to some memory, let's say 1000H. So every time the memory allocation done for this particular variable is fixed. It is not going to be same. So it is written that the same storage will be allocated for each activation. The value of the local name retained across the activation, right? So for all these 3 call, the value of A will retain. So during the first call, if I have assigned 35 value to A, the same value reflect for the second call. Now inside the second call, if I add 1 plus 1 to this value, and it will become 36, and that 36 will be carry forward for the third call. So value will retain across all the activation. So storage and value will remain same for the multiple activation of the same procedure. Now here the limitation is the size of that data object must be known at the time of the compilation. We cannot go for the recursive procedure in this case, because as we have discussed that storage will remain same for all the activation. So if we want that the variable value should be changed for each call, in that case it is not okay to go with the static allocation. And the last is data structure cannot be created dynamically. Now the second is the stack allocation. Now the storage is organized as a stack. Activation records are pushed and popped as activation begin and end. So once I am having P1 is in execution, then the activation record of the P1 will be pushed inside the stack, and once the P1 is execution of P1 is done, the activation record of the P1 will be pop out from the stack. Now the locals are bound for the fresh storage for each activation. So now if I am having 3 calls for the P1, for all 3 times the variable A may get the different memory location, right? So here the fresh storage will be allocated for the each activation, while in case of the stack the same storage will be used for multiple calls. The values of the locals are the deleted when the activation is end. So after the first call, the value of A will be deleted. For the second call, the new storage will be allocated, and the new value we can assign to this A, because the old location and the old value is already free. The size of the data object must be known at the time of the compilation, which is same as the static allocation. Now the third is the heap allocation. Allocation and the deallocation of the storage is done at the runtime. Now some extra time and the space overhead is there to manage this heap, but the other better part is it is okay if we don't know the size of the data object at the compilation time. Now, the overall structure of the memory is divided into the 4 parts. The first is the code part. which mostly the fixed portion, because the memory required to load our program will always be the fixed. We have already written our entire code. Next is the static data. So whatever the static allocation have been done by your program, that is available in the static data section. Then the stack part, so whatever the stack allocation will be done by your program, that will go in the stack section, and this will be the dynamic one, because as we have discussed that the this will done at the runtime, right? So this may grow, but it will grow in the downward direction. And the fourth one is the heap. So heap is again done at the runtime, so this can also grow, but it will grow in the upward direction. And whenever this stack and the heap will match, the further memory allocation cannot be done for this program. So only the static data will be allocated at the compile time. The stack and heap both will be allocated and managed at the runtime. That's it about the memory allocation and the management. Thank you.